and you need the starting value, and that's pretty much how it works. So if we have here, it would be a sub 15, our 15th term that we're looking for, is equal to our start, a sub 1, which is 2, okay, plus n, meaning 15, minus 1. Remember, minus 1 is part of the formula. It didn't just poof out of thin air. Okay, times the common difference. What is the common difference here? Isn't it 7? Okay, so then we clean this up and we'll figure out what the 15th term is. So this is 2 plus, what is that, 14 times 7? So take a moment and compute that real quick, and we get that this is equal to 100. Okay, any questions on this? Okay, so let's have you try one for a moment. Let's do 8, 3, and negative 2, dot, dot, dot. Okay, and I want you to tell me what the 10th term is. Okay, so take a moment, see if you can figure this out. Remember, you need the start value and the common difference, and see where we can go from there. Okay, so here we go. A sub 10 is equal to our start, which is 8, plus our term desired, 10, minus 1. Now, what is our common difference here? How do I go from 8 to 3 to negative 2? Okay, aren't we subtracting 5? So we're going to multiply by a negative 5. Okay, so let's see what this cleans up to give us. We get 8 plus 9 times negative 5. Okay, so that's going to be negative 45 plus 8, essentially. And this gives us negative 37. Okay, so you see, it's not hard. It's a lot easier, actually, just to go ahead and use the formula to figure out what term in the sequence are you actually after. All right? Okay, so now that you know how to find any term desired, okay, can we again relate this back to something linear? All right, so let me just review real quickly with you this following formula that we've seen countless times already. Okay, y equals mx plus b. Now remember, what did m stand for? Okay, it standed for the slope. That's right. And b stood for the y-intercept. Okay. Is there a way that this arithmetic sequence, meaning something with a common difference that's constant throughout the entire sequence, can we get an equation to sort of model this? Well, the answer is yes. And we can use that, we can get to this by using the formula for finding a given term in the sequence. Okay? So for example, this time I'm not interested in asking you to finding a term. I'm asking you to now write an equation for any term with the following sequence. Okay, so we've got 6, 13, 20, and 27. Okay? So write an equation for any term. Now the formula that we used just a few moments ago was to find a specific term in the sequence. Now this equation, if I was to use this and apply it, I should be able to get any term in the sequence that I wish. And let me show you how this is going to work. You're still going to use the same general formula, which is a sub n is equal to a sub 1 plus n minus 1 times d. Okay? So again, the only two things that are really specific here are your start value and your difference. So what is the start value here? It's 6. Okay? Plus, now, do I have a specific term that I'm desired to find? No, I'm actually interested in finding any term, so I'm actually going to leave that as n, because I'm not actually sure what term I do want to find. I know I want to be able to find an equation that will find any term that I'm interested in, though. Okay, subtract 1. What's the common difference here? If you go from 6, 13, so forth, it's a 7. Okay, and all you have to do is take this expression and simplify it. So I've got a 6 here. With the 7 being on the outside like this, can you imagine what I'm going to do here? You're just going to distribute to both things in parentheses. So 7 times n is plus 7n, and 7 times negative 1 is minus 7. Okay, clean this up again, and I get 7n minus 1. Okay, now that right here is money. That right here, I can match that up perfectly if I wanted to y equals mx plus b. Okay, this meaning a sub n equals this. This is what the sequence is. And if you could think about it this way, you've got y equals mx plus b for a moment. The slope of this line, if you were to use mx plus b, would be 7. And notice what was our common difference here. What was the common difference? How did the numbers go up by each increment? It went up by a plus 7. That's why our 7 is a slope. That's why this sequence, if I wanted to, it would make a straight line. Okay? And this is how it models after a linear equation. Okay? Because if you wanted to, you know how to graph this. You would just start at negative 1, okay, and go up 7 from that and over 1, up 7 over 1, up 7 over 1. Play to connect the dots and you have a straight line. And you notice that the numbers that you'd hit would be 6, 13, 20, and 27. And if you like to, as a little, discovery, you can actually do that little assignment on your own. Actually graph this and see how do these numbers in the sequence fall into the graph. Okay, and then you'd make the connection that the sequence and the linear equation go hand in hand with one another. Okay, so let me conclude this with a try problem real quick. Okay, and here is the try problem. Same thing, I want you to find an equation for 7, 6, 25, and 34. Okay, take a moment, pause the video, see if you understood what I've just done here. Remember, just as a little hint, all you need to have is the common difference and the first value, and you should be able to simplify the expression. Okay, so here we go. The formula again is a sub n is equal to a sub 1 plus n minus 1 times d. Okay, a sub n is equal to, the start value is 7 plus n minus 1. What's the common difference here? And I believe we're adding 9 each time now, so it'll just be a 9. Okay, distribute and simplify the expression. So 7 plus 9 times n is 9n. 9 times negative 1 is a negative 9. Again, combine like terms here, and we get 9n minus 2. Okay, so again, if I wanted, and just to show you this, what if I did want a sub 1? I wanted the nth term, the first term here. Okay, what was our first term that we had? It was 7. So all I would have to do is take 1 and plug it in for n. 9 times 1 minus 2, and that gives me 7. If I wanted to find the 20th term, a20, it would be 9 times 20 minus 2, which is 178. See how easy that was? And again, it's all based off of this equation right here. Okay, this formula. Okay. That concludes the lesson. Please attempt to do the homework the best of your ability. And of course, if you have any questions regarding any of the assignments, we'll tackle those in the webinar. Hope you guys have a great day. Thanks for listening.